In this example, we have a bright orange crystalline substance and we are given its percentage composition by mass and we are asked to find out its formula. Notice, here we are not given the molecular weight of the compound. Let us see what's going on here. Now, from the percentage composition, we understand that there is this much of sodium and this much of chromium and this much of oxygen in 100 grams of the substance. That's what we mean by the percentage composition by mass. And these are the molar masses of their atoms. You will be able to look up these molar masses from the periodic table, or sometimes you may have to memorize them. And if you divide the given mass with the molar masses of their atoms, you would get the number of moles of atoms of that element or the amount of substance of that element in 100 grams of the substance. Again, pay attention to the units, and upon simplification, these are the numbers that you would get. And to get the simplest ratio, you have to divide these with the smallest of these three, and that is 0.761 mole. And this ratio then becomes 1. This is again 1. Actually, this must be a 3, and it is approximately 1 within the experimental error. And upon simplification, this ratio gives you 3.52. But if you look at the simplest ratio, it came to be 1 to 1 to 3.52. Now, this ratio is not in whole numbers. First, you have to make sure that the simplest ratio contains only whole numbers. For that, you have to multiply this simplest ratio with 2. Then it becomes 2 to 2 to 7. You can take it as 3.5. Ignore this 2. So then the empirical formula of this compound becomes Na2Cr2O7. Remember, sodium dichromate this is, and it is an ionic compound. For ionic compounds, the empirical formula itself is taken as the formula of the compound or the formula unit of that compound. So this is the formula of the compound, because ionic compounds do not contain molecules. So there is no molecular formula for sodium dichromate. The empirical formula itself is its formula.